Okay, here's a video about C++ arrays. Right now I have an array declared called an array, and an array can store ints, and it will have 7 elements. And we know that because the dimension of this particular array is indicated using the variable size, and the constant variable size has the value 7. So let's just see what happens. Just want to verify that this runs, right? Okay, and it's going to run and it doesn't print anything because I didn't do anything with the array. All I did was declare it. Okay, big deal. Well, I just wanted you to know that it ran. Now let's take the const off that and let's run it again. Okay, so now we have build errors. No, we don't want to run it because there are errors. And the error was that the expression, namely size right here, must be a constant value. In other words, it must be a value that won't change. And since there's no const on this variable here, variable declaration here, it's possible that the variable size will change value. So I can't use that. Okay, these types of arrays in C++ are called fixed size arrays because the size of the array must be set at compile time. In other words, when you write the program, the size of the array must be fixed in such a way that it will not change, because the compiler actually does some of the work before you run the program, determining where the array is going to be allocated and how much room is needed for it. Now, sometimes you'd like to do something like this, right? Sometimes you'd actually like to have a variable size, and not even just assign something to it, but ask the user for the size. This would be a handy thing to be able to do. Of course, I'm not going to be able to do this. We see the red squiggly line here. I'm not going to be able to, but it would be nice to be able to, if the user wanted to store a bunch of values, ask them how many, and then allocate my storage to be at that size. Can't do it. Can't do it if I'm using a fixed size array in C++. So for this type of a task, C++ provides a different type of array. Whereas a fixed size array is handled at compile time by the compiler, and all the memory allocation of that is determined at compile time before the program runs. There's another type of array called a dynamic array. And a dynamic array is actually allocated at runtime, hence the word dynamic. And the way you declare a dynamic array is you declare your array to be a pointer. So here, when I say an array equals star, I'm saying an array is a pointer to an int. Now, right now, I don't have an array. I just have a variable that can point to an int, a variable that will store the memory location of an int, right? So you're familiar with pointers. Okay, but I have no array yet. Now, to create an array, to create a dynamic array in C++, I say new, and the type of element in the array, and how many elements need to be allocated. And this particular statement here is going to be executed at runtime when the program is running. So when I say new int size, a whole block of memory, size elements wide, is going to be allocated, and the address, the location of that memory, is going to be returned. And where do I want to put it? I want to put that location or that pointer value in the variable an array. Okay? So great. So now what I have is an array that can be, I have an array of ints, and it can be a different size every time I run the program. Okay? So this is a different kind of animal, right? The declaration looks totally different. The creation of the array looks totally different. Okay, so now it starts to look like things are going to be complicated, right? It starts to look like things are going to be complicated, but not really, because the cool thing about a dynamic array is that you actually use it the same way you would use a regular array. So once I have this dynamic array created, okay, then I can just do the same kind of stuff that I would do with a regular array. Let's suppose I wanted to fill up the array with the number 7. Okay, well, I'm writing a little loop here that loops through the array, that indexes through the array, and assigns a 7 to every element. Let's suppose I wanted to print out all the elements in the array. This is the same way I would write the code to do the same thing to do this task with a fixed size array. And my code is actually going to be the same with a dynamic array. So when you're using a dynamic array, the joy is it can be a different size at any time. I guess the downside is it's created at runtime. That can be up or down. It's up because I can change the size. It's down because it is one extra thing that's happening during the run of the program. Again, code-wise, once you've actually created the array, you can use it in the same manner as you would a regular array. And let's just run this so I can verify for you that that's what happens. Okay, so I have my 5 7s in my array. Okay, very simple example, but the idea is this is how you create a dynamic array. This is how you use a dynamic array. And again, why would you do this? Because if you wanted the flexibility, okay, of being able to determine the size of the array at runtime, because you might not know it prior to the runtime of the program, then you can use a dynamic array. Okay.